Now we're going to make some graphical displays of data. So there are certain things. We make certain kinds of displays or graphs for numerical data and others for categorical. There's much fewer for categorical, so we'll do numerical first, but I want to state ahead of time that we need to kind of have certain characteristics of these graphs to make sure that we're communicating things correctly. So things that we need context, and so if we have any axes, we need to make sure that they're labeled, and we have to have a key provided, and key provided, that's most important when we're doing stem and leaf plots. We need to have a scale, and so have consistent spacing and a jump or skip from 0, and those are in numerical data displays sometimes, in a histogram or maybe in a dot plot. We could have that as well. And then a title, just kind of saying at the top to our reader, this is what you're looking at. Give it some kind of context of the situation. So this jump or skip, I'll put an example here that if we made a dot plot of heights of students and we sampled 10 students, let's say they're all in high school, and so those high school students vary from heights from 60 to 70 inches, from 5 feet to 5'10". If we made a graph that went by every 10 inches, let's say we had this space, our graph would all kind of be scrunched up here if it was between 60 and 70, if we started at 0, 10, 20, all the way up. So instead of doing that, we can do a skip. And so if you put 2 slash marks, that's saying, hey, I know the vertical axis is 0, but there's nothing going on here before a certain point, so we're just going to kind of scrunch up the graph. And so because this is starting at 60, I put my first tick mark here at 60 and count up 1 inch at a time and get up to 70 inches. So, and then I put my dot plots and that. And so now we're able to use the space better. We've got our axis labeled and used. I have height in inches, and we have the values in there as, I did it freehand, but it's pseudo uniform, and then I put my dots on. But that jump or skip is just those slash marks to say, hey, we're skipping a lot of the values before we get to where the action is. Okay. All right. So we're going to start with our first data table, which is called the frequency table. Okay, and for that, we make one column, which is what we're measuring, and then we'll have 4 different columns after that we'll go through. And so this is not actually a graph, but it could help us in organizing our material and numbers to make a graph. So the first thing, we're going to use that set of data from the 10 people, and we're going to use the age of the people, of those 10 people. So you've got that on your notes from the page before. It has the Kentucky woman who's 61-year-old first. And so the first thing we do is we tick off by age and we categorize them in the right thing. And so one thing is, with the age, I chose to start with a class, and for this, the class width is 10 years. I'm putting in 20 to 30, 30 to 40, 40 to 50, 50 to 60. So that's a class width of 10 years. And so each of these are classes. Okay. And so I want to make sure that my first class captures the lowest age, and 22 was the lowest age of anyone in that. And then I want to make sure I've captured the highest age, and so 61 was the highest age, and so I put that up to 70. Okay. And then I just count. And I get, so 4 people in their 20s, 3 in their 30s, 2 in their 40s, none in their 50s, and 1 in their 60s. Okay, so talk about the labeling here. 20 to 30, 30 to 40, and so sometimes you'll see that, and you're like, well, wait a minute. If I have someone who's 30, what group is that included in? And so that would be included in the upper level. And so when you see 20 to 30, really what that means is the value is greater than or equal to 20, but less than 30. And so basically it's 29.999 is the upper end. So 20 to 29.999, 30 to 39.999, and so forth. And so the 30-year-old person gets categorized in this group from 30 to 40. Okay? So if we're counting them out, 4 in their 20s, 3 in their 30s, and so forth all the way. And that's the frequency. And so that could help us make a histogram or a dot plot or something like that. The next thing that we're going to look at cumulative frequency, just how many are of that age or lower. And so when we start with that, we'll say, okay, we're going to start with none, and then in our first class, we've got 4. And then to get to the next cumulative frequency, we're going to take that 4 and add what's in the next group, 3 in their 30s. And so there are 7. And so basically we're saying there are 7 people younger than 40. And do the same all the way down. All right. So when we did our frequency, we wanted to make sure that the sum of those is equal to the number of people that we're looking at, which it was. And for the cumulative frequency, we want to make sure that that number on the bottom matches all of the people there, all of the items that we're looking at. In this case, it's 10. All right. For the relative frequency, a little bit different. So for the relative frequency, we're looking at the proportion of people. And so you can express it as a fraction or as a decimal or as a percent. I don't particularly care. At some point, I'd probably want to see the fraction, but you don't have to have that as your final answer. So relative is out of the whole group. And so for this, in the 20 to 30, this is basically just like the frequency, except you're dividing it by the total number of people that we're looking at. So this is 4 out of the 10 people that we're looking at. Okay, 4 out of the 10. And then as we go down further and further, 3 out of the 10, 2 out of the 10, 0 out of the 10, and 1 out of the 10. Okay. And the cumulative relative frequency kind of works the same way. We'd start with the 4 out of 10. And then to get to the next group, we'd add the 3 out of 10 that we have here. And so we'd add 4 out of 10 plus 3 out of 10. That gets us 7 out of 10. And do that all the way down. This is 2 out of 10. You get the idea. This would be 9 out of 10 in here. This would be 0 out of 10, 1 out of 10. This would get to 9 out of 10. This would again be 9 out of 10, and then 10 out of 10. So the bottom number on this always has to be 100% or 1. And the sum of this column always also has to be 100% or 1. So that's it for our frequency table, which helps us to make graphs. Okay.